just restarted recording.
Did you really?
Yeah, you don't have to. You can just start recording. I have the time right here, so you can just tell me when to go.
You go. Okay.
Good morning. This is our conceptual design review for DirecTV. Our team members consist of Fernando Vega, John Rosella, Christian Ocampo, and myself, Victor Elvira. Our faculty advisor is Hagop Engine. DirecTV liaisons are Jose Perez, Ophelia Quintero, and Tung Shin Lin. Our agenda for today is I will be introducing the introduction, and what I will be talking about is the background, the problem, the scopes, and the deliverables. Fernando over there will be talking about the organization chart and the Gantt chart. The technical, we'll leave it to Christian to talk about all the requirements, the diagrams. And for our trace study, we have John talking about our verification and validation. And our risk assessments and conclusion, also followed by our summary, is going to be by Fernando. Huh? Oh. That's me still, right? Okay. DirecTV is one of the world's leading providers of digital television.
Present the slide number, yeah. So say the slide.
Slide number?
Or just the slide title.
I need to add
Oh.
I need to add slide.
Slide title?
So say the title, yeah. Sorry.
Okay.
Continue.
So this is the company background. To talk about more, DirecTV is one of the world's leading providers of digital television entertainment services, delivering a premium video experience. DirecTV is the worldwide leading in customer service as well. And we're gonna look at right now one of the some of their accomplishments that they've been able to accomplish over the years. One of their accomplishments is that obviously in 1990 they were founded. In 1994 they launched a satellite, and their service was launched. But it took 1 year for them to reach 1 million customers. And by 2010, DirecTV was the world's largest paid TV provider with more than 27.5 million customers. And for today, DirecTV is the first TV provider to to launch 4K content to more than 39 million customers. So DirecTV problem. One of the DirecTV's problems going on right now is that there's a lot of airspace. There's a lot of wireless communication going on around everywhere. We have Wi-Fi. We have Bluetooth everywhere. It's expanding so much that DirecTV is having interference with all these things going on at the same time. So one of their problems is that it has a variety of interference with their television signal. So this can mess up the signal as far as locating and receiving all the channels that you want. And one of the things is that it's hard to diagnose where the problem is coming from. So what we're trying to do here is trying to locate the problem. But in order to locate the problem, an engineer has to come in and set up his equipment, and it's a very expensive equipment. And the thing about it is that it's not even portable. So it's very hard to lift, heavy to lift, and it's a struggle for any engineer to go to any of the customers' households and diagnose the problem with such a heavy equipment. So this is a picture of a spectrum analyzer, and it costs up towards $100,000. So it's very expensive and it's also very heavy as well. So you can see how the problem is where, you know, something like this would be kind of a hassle, and especially if it were to get damaged along the road or something like that, it can be, you know, it can be, it can have even more trouble. Hey, fool, I'm done. Our project scope. What we're trying to do here is we're trying to program a software-defined radio, which is also known as SDR. Basically, what it does is receives we can program it to locate interference with DirecTV satellite signal. So this costs around This costs around $675 to purchase. This is a picture of what it looks like, and what it does is we can program it to.
You're not seeing what it does. Not yet.
Not yet.
No, there's no slide for it.
For this one, you just want to say this is an example of an SDR, because we're
Oh,
gonna
that's
get
it.
into
Alright. Some of the additional components that we use for this SDR is the USB drive. Oh, these are deliverables. You just went another slide. Alright,
No,
that's alright.
What's wrong with it?
Yeah. So our project deliverables are to deliver a software-defined radio. Along with the radio, we need USB drives as an additional component. We need a well-programmed code to go into the USB so that we can play around with the SDR. Also, what we need is a digital video broadcast modulator. Basically, what this modulator does, it modulates the signal that we need in order to change the frequency if we have to, or the offset, or anything that would be related to any of the customers' problems, or anything that they have a problem with that we can diagnose. So if there's a frequency that's super low or super high, with this modulator we can modulate that signal and see how we can fix it here. Do I have to mention we have a final report? I don't know.
Yeah, just mention it's part of the deliverables.
So, and another thing that we have to deliver upon is a final report to DirecTV and also to CalStat LA. Next, we have Fernando to talk about organization chart and the Gantt chart.
Okay. I'll take your spot right here. The transitions have to be quick. So, this is our project org chart, and this is basically how we set up. And as part of our project management, we organize what the project is going to look like and what different tasks and responsibilities each team member was going to have. And so we started off at the beginning of the project. We agreed that I would be project lead for the project, and we were under authority. Okay, so our liaisons were Ophelia Quintero, Jose Perez, and Tang Shen Lin, which was later introduced to the group. Our technical review is Dr. Hagap Injian. And going down the project org chart, we have John Rosella, who's in charge of all budgets and all purchase orders that the team will make. And then we split up the design, or the main chunk of the project, between design, verification testing, and validation testing. Under detailed design, we had SDR calibration for Victor Vera, synod identification for myself, Fernando, signal processing for Christian Ocampo, and risk reductions done by John. And so here you can see a schedule of our fall quarter and what we managed to accomplish within the last 2 months. And so some of the big things that we have done is we are ahead of schedule. And so with that, we have our SDRs, our trade study done, completed, and we put in orders and received our SDRs. We have our testing equipment for our modulator is in-house already, and we have all our programs and software ready to use. all of our contract negotiations were also complete during this quarter. Our project planning is already complete, so we have everything mapped out, which you will see on the next slide, from here to May, and we are ready to begin phase 2. And so you see here that we are currently in, by then it'll be the end of November, and so we have just finished up our conceptual design, no pointing, and we're beginning our phase 1 and 2 design process, which will be followed by phase 3 test and evaluation. And finally, our final reports and our presentations will be further down. And so do you have the agenda here? Okay. And so I will pass on. Now I will introduce team member Christian Ocampo to talk to you about our requirements and our design.
Can you do this?
Yeah. You might go over there. I can see you.
Minus 1 minute.
We're gonna
Thanks a lot. So our next slide shows the requirements, and most of these requirements are actually from the customer. Starting off with the very first one, our channel frequency should be from 950 to 2200 megahertz, which is the DirecTV channel frequency. Our SDR should be capable of handling signals coming in that frequency. The next requirement is frequency range, which is from 2 megahertz to 6 gigahertz. So our SDR should also be able to handle the frequency outside of the channel frequency up to 6 gigahertz. The third one is the power level, which is from negative 69 to negative 10 dBm. But just a side note, the DirecTV signal actually has a RF input power of negative 69 to negative 45. The number 4 is the roll-off. All filters should be around 20%. Fifth is modulation mode. Our SDR should be able to demodulate QPSK and APSK. And 6 is symbol rate, which is 30 megasymbols per second. So our SDR should be able to be at least twice that, because that's the Nyquist frequency. And 7 are the functions that DirecTV asks of us, so our SDR should be able to display the RF signal, as well as calculate average power and calculate the SNR. And then 8 is the signal processing. So after we have all those initial calculations, our SDR should be able to also calculate the timing error, the phase error, the carrier error, and the carrier frequency error, and as well as recover timing, carrier, and phase. And lastly, the important one is that our SDR should be able to interface with DirecTV LND. So before I get into the diagrams, I just want to define a few words, just so everybody would know. Let's start with software-defined radio. It's basically a communication system, so it would have everything that a typical communication system would have, such as mixers, filters, amplifiers, modulators, and so on. But instead of being implemented in hardware, it is, as the name says, it will be implemented by software. And also, I would also like to define GNU Radio Companion. I just want to let you know what it is. It's a software it's the software that we will be using, and what it does is basically a tool that generates source codes based off flow graphs that we generate inside the GNU library. So now let's look at the flow chart. This is a very top level flow chart. We'll start with the very first one, which is the most important one, the signal interface. So our SDR should be able to connect properly with the LND and be able to get the signal. And next we will digitize it, which will be done when it's connected to the computer. And after that we will use the GRC software, as well as anything that's not defined in GRC. We will do it in Python to deliver the code. And using these two programming languages, we will get power calculations, which as previously mentioned, as well as demodulation, and finally display the signal and the results. And then this is a more accurate, this is a more well-defined block diagram. Once again, we start from the top, from the DirecTV LND. However, in order to, based on our LND research, the proper way to connect an LND to an SDR would be first to connect it to a splitter, and then in this splitter we will also have to connect a DC input, which is either 15 volts or 18 volts, and then from the splitter the output will be connected to the SDR. And as you can see here, there are codes within the SDR, and that's just to show that our SDR has been programmed to implement certain functions. And this SDR is then powered by a USB coming from the computer. And it's also commanded from the GRC companion. And so going outward of the SDR, it will display modulation accuracy results, as well as graphical displays, which will be shown in frequency spectrum, the scope, and the constellation.
What is that?
Yeah.
Oh, it's a little key recording.
10%.
Yeah, up to 5.
And now this is a more visually appealing diagram, which shows ideally how our system should work. Once again, we have the LND, and then here is an image of the splitter, and then we have a power inserter connected to one side, and then the SDR connected to the other side, and then it will connect to the laptop and finally display the GNU Radio Companion software. And then next, we will have the trade study, and I will hand it, and the verification and validation, so I will hand it to John for the next couple slides.
Go, John. John, see. Alright. After we do this.
So in order to start phase 2 of our project, we had to choose a software-defined radio system that meets DirecTV's requirements. And in choosing this system, we had to compare them through a weighted rate study and made our decision based on the results each SDR would get in 9 different criteria: cost, additional devices, learning curve, and operating frequency, symbol rate, type of duplex it has, sample size, interface speed, and the type of transceiver the chip installed in the SDR. Now, in our hardware selection, we found a total of 7 software-defined radio systems that can be used in our project. Starting on top, the first SDR on the left of the screen, we have the Blade RF 115K, followed by the USRP B100. Third on top, we have the Hack RF1, and then the Blade RF 40K version. Starting on the bottom left, we also have the USRP B200, followed by the USRP B210, and finally the FMCOM S4 EBZ. Now in this weighted trade study, we ranked the SDRs from 1 to 7, where 1 is the best and 7 is the worst. We also considered which of the 9 criteria should have the higher or heavier score. And based on our research, the time limit we have, and our senior design budget, our top criteria are cost, learning curve, and the SDR's frequency range, and its symbol rate. As we ranked the SDRs with one another, we down selected to the top 3 SDRs: the USRP B200, USRP B210, and the FMCOM S4 EBZ. As you can see in the chart, most of the specs of the 3 SDRs are almost similar, if not the same, with the exception of the additional device for the FMCOM S4 EBZ, which requires an additional external FPGA device in order to work. All 3 SDRs meet DirecTV's signal requirement with a frequency range of 70 MHz and 6 GHz, and a symbol rate of greater than 30 megasymbols per second. In addition, all 3 SDRs have a transceiver chip which provides 0 intermediate frequency, which means there's less frequency interference to deal with. In the end, we chose the USRP B200 as our best ideal system choice for a senior design project. Next, I will discuss how we plan to verify our actual receiver device when we get to phase 2, which is the actual build. One thing to mention is that our project is heavily focused on coding or programming of the SDR. To verify our code, we will test it with the least amount of risk or interference by simulating it in GNU Radio. Afterward, if everything goes well, we can move on and test it with a simple signal generated by a modulator device provided by our liaisons. And finally, live testing with DirecTV satellite's actual signal. Now, I'll give the stage back to Fernando Vega as he discusses risk assessment and to conclude.
We should say it. Okay, so